So the first thing we want to do here is we're being asked to find all the half angles of this particular triangle. Now this one you weren't originally given the hypotenuse here, but this is one of the Pythagorean triples. If you didn't happen to recognize that it is, then you can always use the Pythagorean theorem in order to find the missing side, because we are going to need the hypotenuse on this so that we can find the cosine value, because that's going to be used in all of our formulas. And when we look at tangent also has the sine involved, so we'll need to know the opposite and hypotenuse side. So that's why we got to find that side. So since we know all the sides, I'm going to find the sine first. So we're going to find the sine of the half angle. And the formula for that is plus or minus the square root of 1 minus cosine over 2. So what we're going to do is we're basically going to replace this cosine with the cosine of this triangle, which is the adjacent over the hypotenuse, or 15 over 17. Now what I want to do is I want to rewrite this 1 because we're going to have to subtract our numerator. So I'm going to rewrite the 1 as 17 over 17. So I'm not changing the value of it, I'm just changing the way that the 1 looks. And then we're going to divide all that by 2. So we're going to subtract the numerator. 17 minus 15 is 2. That's all over 2. So we can think about the 2 as a 2 over 1. So we're dividing by a fraction, so we want to keep, change, flip. So here we have a 2 in common on both the numerator and denominator, so those cancel. So we get plus or minus the square root of 1 over 17. Now, whenever we take the square root of a fraction, we take the square root of the numerator, which would be 1, and the square root of the denominator, which would be the square root of 17. So we need to rationalize here. So we get the square root of 17 over 17, and then we bring along the plus or minus. Now the next easiest part to find is going to be part D, because these two are reciprocals of one another. So since we know that they're reciprocals, really all we need to do to find the cosecant of the half angle is to flip what we got for sine. Now we can start here, but if we flip that, notice that we're going to have a square root in the denominator. So we can go back to our previous step right here, which is where we found what it was before it was rationalized, and we can just flip that to save us some work. So we can put the plus or minus. Now we're going to flip that to become the square root of 17 over 1, which simplifies the plus or minus the square root of 17. So the next one we're going to do is part B, which is the cosine of theta. Theta over 2. So we get plus or minus the square root of 1 plus cosine theta, and that's all over 2. So again, we found the cosine on the last one. So again, I want to rewrite the 1 to have the same denominator. So the cosine was 15 over 17. So again, just like the last one, we want to rewrite our 1 as a fraction so that we can just go ahead and subtract. Oops, that should be a plus. Okay, so now we're going to add these two. So we end up with 17 plus 15, which is 32 over 17, and then that's all over 2 over 1. So we keep, change, flip. Now here, if we look at the 32 and the 2, they both have a 2 in common. So 2 divided by 2 is 1. 32 divided by 2 is 16. So we end up with plus or minus the square root of 16 over 17. Which I'll bring over here since I have a little more room. So we are going to take the square root of the numerator and the denominator. square root of 16 is 4. Square root of 17 is square root of 17. So again, here we need to rationalize. So we end up with 4 square roots of 17 over 17, and then we bring along the plus or minus. Okay, now the next easy part to find is going to be part E, because these two are reciprocals of one another. So I'm going to put part E over here in purple. But for part E, basically what we can do is we can, very similar to what we did for part D, when we went back to before we rationalized, we can do the same thing here. And we can flip the fraction from right at this point. So that would be, second. Equal to plus or minus, and then we're going to flip this fraction to be the square root of 17 over 4. Okay, now the last one that we have to find is the tangent of theta over 2. So that is going to be part C. And the formula for that is sine theta over 1 plus cosine theta, or you could use this one. It doesn't really matter. You'll get the same answer regardless. I'm just going to use this first one over here. So sine theta over 1 plus cosine theta. So we're going to fill out what they gave us. Now this one doesn't have a plus or minus, so we don't have to worry about that. So if we go back to our triangle, the sine is the opposite over hypotenuse, so 8 over 17. No, I don't want to write that. It's a 1. So if we think about what our cosine was, it was 15 over 17 from the previous two problems, 15 over 17. So I'm going to rewrite this 1 as 17 over 17. So if we add our denominator, we get 32 over 17. So we have a fraction over a fraction, so keep, change, flip. So if we look here, they both have a 17 in common, so those cancel off to become 1s. And 8 and 32 both have 8 in common. 8 divided by 8 is 1. 32 divided by 8 is 4. So if we multiply across, 1 times 1 is 1. 1 times 4 is 4. Now the last part, which is part F, which is the cotangent of the half angle, we can take, since cotangent and tangent are reciprocals of one another, all we got to do is take what we got for the tangent of the half angle and flip it, which would be 4 over 1, which simplifies to 4. Okay, so what we're being asked to do on this one is, or 2 and 3, is we're being asked to find the sine, cosine, and tangent of the half angle. And what they give us is they give us 75 degrees. So if we go and we look at, so the first one we're going to look for is the sine. And the formula for it is sine of theta over 2 equals plus or minus the square root of 1 minus cosine theta over 2. Now, if we look at 75 degrees is going to be located in quadrant 1. So in quadrant 1, our sine values are positive. So we're not going to use the negative part of our formula. We're only going to use the positive part. So really, I don't even need any of this. Now, the reason we didn't do that on the other problem is because we don't know where that triangle is in space. So that's why we leave the plus or minus there. So what we want to do is we want to see how can we rewrite theta that when we divide it by 2, it equals 75. Well, the nice thing is there is an easy way to find that. If we take our angle and then we multiply it by 2, we get 150. If we took 150 and we divided it by 2, we get 75. So we want to rewrite this as the sine of 150 degrees divided by 2. So whenever we fill out the formula, the angle that we're going to be using, theta, is 150. So that's what we're going to use as the angle that we get the cosine value from. So again, cosine is our x value. So we're going to look at the x value at 150 degrees, which is up here in this quadrant, which is the negative square root of 3 over 2. So we fill that out. Now here we have a minus and negative, so that's going to turn this to a plus. Now, don't try to simplify this at all. We're just going to leave our answer like that. Now for cosine, we've actually already found the angle that we need. So if we plug everything into our formula, and again, cosine, this is in quadrant 1, and notice everything in quadrant 1 is positive. So we're going to have 1 plus, well, the cosine of 150 degrees, which we said was negative square root of 3 over 2. So that's going to change this plus to a minus. And then we're not going to worry about simplifying that. So we do the same thing for tangent. The formula for that is the sine of theta over 1 plus cosine theta. So again, theta in this case is 150. So that's what we're using as our reference. So we're going to, the sine at 150, that's the y value. So the y value there is 1/2. And then in the denominator, it's going to end up being that negative square root of 3 over 2 again. So that's going to change that plus to a negative. And again, we're not going to worry about rationalizing the denominators here. I care more about the trig part. Okay, so number 3 is going to be worked the same way as number 2. So if we look at this angle, this angle is going to be located in quadrant 1 again. So notice all of our values are positive. So when we look at sine and cosine, we're going to ignore the negative part of the formula because we know where it's located. We know it's located in quadrant 1. So what we need to do is we need to take our angle and we need to multiply it by 2 so that we can see what do we want to use on our unit circle, which in this case would be 45. Oops. So we can rewrite this as the sine of 45 degrees divided by 2. So the formula is 1 minus cosine theta, which in this case is 45, all over 2. So again, for cosine, we're going to be looking at the x value at 45 degrees, which is the square root of 2 over 2. And again, we're not going to worry about trying to simplify all that. We'll leave it alone. For cosine, we're going to do the same thing. We're going to take that 45 degrees, divided by 2. So really the only thing that's going to change is this sign here. It's going to change to a plus because the formula is just different. So we get that as an answer. And then the last one is tangent. So again, we're using the formula down here. The theta in this case is 45. So we're going to look at the sine of 45, which is the y value there, which is the square root of 2 over 2. And then from the previous two, we saw that the cosine value was also the square root of 2 over 2. And again, we're not going to worry about rationalizing.